And now it's on to part 2 of your 1.3 notes. When you're solving an equation and occasionally something strange happens, indicating that there is either no solution to this equation or there is more than one. So we'll show you exactly what that looks like and how that happens. First, example 3a, 3 times the quantity 5x plus 2 equals 15x. First, we write that equation down and notice that we will have to use the distributive property. So that gives us 15x plus 6 equals 15x. And that already looks a little bit suspicious, seeing that 15x on both sides. But we go ahead and start solving as though we normally would, as if we normally would. And we want to get the x's together, so we subtract 15x from both sides. What happens is we end up with 6 on one side and nothing or 0 on the other. So now we have a statement that says 6 equals 0. We don't know what x equals because there is no x left. The x's have completely dropped out of the equation. This tells us that since 6 can never equal 0, in other words, that's a false statement. It's never true. So therefore, the equation has no solution. No matter what x equals, this equation would never be true because x's are going to cancel out anyway, and we're going to be left with 6 equals 0. Now, on to part B. For part B, we have negative 2 times the quantity 4y plus 1 equals negative 8y minus 2. So we're going to use the distributive property again. After we rewrite the equation, we get negative 8y minus 2 equals negative 8y minus 2. Again, that looks strange, but in a slightly different way. So we proceed to try to get the variables on one side by adding 8y to both sides. And when we do, we're left with negative 2 on this side and negative 2 on this side. Now, once again, the x's, or the variables, have canceled out on both sides of the equation, but we're left with this statement that's actually true. And since negative 2 is going to always be equal to negative 2, it's always true. So that means that the equation is called an identity, something that is exactly equal on both sides, no matter what the variable is. And therefore, this equation has an infinitely many solutions. Any real number will work for y, because once they cancel out, you're going to be left with negative 2 equals negative 2 every time. So this concludes example 3, and now go on to the next video for example 4 for your notes.